everybody. How we doing out there today? Another edition of Takeaway After Dark. I'm seeing all of a sudden huge number of names logging in at one time really fast. So they're like, oh wait, we gotta get there. So welcome everybody. Welcome to another Takeaway After Dark, part 5, all right, for tonight. And you're looking at us right now, and you're wondering where we are. We're actually, the three of us are not far from each other. Like last week, when you joined us, we sat right next to each other in Rhode Island. This week, we're actually in Chicago. We spent some time here with some of our local reps, doing some training classes, some meetings. Local guys here. We got some Wisconsin coming down, so we have people from everywhere joining us here. And we're actually that far away from each other. So Jason's over here, and John is sitting over there. All right, we're right at the same, but we just decided not to take over the entire lobby of the hotel right now.
Some feedback, Dave. Heard an echo, so I turned my mic off.
Okay, all right. So I can't see any of the comments or questions from anybody out there. So if just want to make sure that how the sound is for everybody out there, how the video is looking for everybody, just let us all know. And while you're at it, of course, type something in, say hi, hello, how are you, what part of the country you're in right now, and if you're here in Chicago nearby, dude, come on in. Well, we're outside in the burbs of Chicago right now, so we're not that close. But if you're locally, what town are we in again? Elmhurst. We're in Elmhurst, Illinois right now. So if you guys or anybody out there is nearby here, come on in. We're in the lobby. And unfortunately, our traditional takeaway after dark with a drink didn't happen. Yeah, we're sucking down some coffees instead right now. So again, in the lobby, no bar here where we're at right now. So anyways,
we got a lot of folks chiming in without even being prompted, so this is cool. And let us know if the sound's better. I think we did a couple of things, so I think we're better off here now.
All right. Everything's good, everybody? Sounds good out there?
Sounds better. There we go. All right.
All right. Good. All right. So tonight's episode of Takeaway After Dark is our great debate on what way is better to zone a system out there when we're looking at zone pumps versus zone valves, and which way do you do it? All right. Which way is better? All right. Which way do you choose? And if you were able to set the rules and everybody had to follow what you said on how systems need to be zoned from here on out, tell me what you guys prefer out there. What, and you can't say it depends.
Yeah, no, that's BS. You got to take a stand.
Right. You got to pick one way versus the other. All right. If you had your preference all day, all night, what way would you do it? All right. So type that in there. We want to see it. I ask this question every year, several times a year, on what is the preferred method of everybody out there in zoning systems out there.
Rich is already screwing with me. He said it depends on whether you have a pressure differential bypass valve or not. McGrath, you're killing me, man. You're just killing me.
Excellent. So what kind of numbers are we seeing? What are we seeing out there right now?
Mostly pumps.
Okay. All right.
Most pumps. We got zone valves. David Samoya says zone valves. I use manifold circs with actuators.
Zone valves.
Zone valves.
Okay.
Here in Minnesota, it seems to be zone valves, says Spencer Steckelberg. So actually, I'm seeing a few more zone valves now popping up. Zone valves.
Good. And that's one thing that I've noticed over the last couple of years, at least 5 years, 6 years, is the number of zone valve systems going up. All right. We used to see huge amounts of zone pumps to zone valves. Used to be almost 4-to-1 systems out there, zone pumps versus zone valves. And I'm seeing zone valves coming up and hitting mid-road now right now. But which way is better? All right. That's the question. All right. So I did ask everybody your preference, but now the question is which one is better out there? All right. So that's the big deal. And that's what we're going to talk about tonight.
Ivan says, what's cheaper? Two things there, Ivan. I don't think it matters a heck of a lot, because I don't think if you go in one way or the other, you're probably not going to lose the job. That's not going to be why you lose their job or not. And I always warn people, never use the word cheaper in front of a customer. He says, why do you do it this way? Well, it's cheaper. That tells the customer you're giving them cheap stuff.
Yeah, you want to talk value.
Yeah, but even stay away from the synonyms for for cheaper, like value engineered or cost competitive, you know, it doesn't make any sense. So
Less expensive.
It's less expensive, or it's just the way we choose to do it.
And I think when it comes down to the cost of a system right there between zone pumps versus zone valves, there's pluses and minuses on both sides. And I think the cost comes in relatively close when you start factoring in labor and other accessories.
Wiring,
You start looking at a parts list, one might be less than the other, but then you got to take into account that labor side of things as well, right? And then space wise, and we'll talk about that. This is what debate for, man. This is what this whole class is for tonight. Definitely.
We got a cost effective, and that's just another code word for cheaper, in my opinion.
Right. Yep.
It's to say it's the way we do things. It's the way we chose to do things because it represents the best balance of performance and value. End of discussion. That's pretty good, huh?
That was good. Yes. And you made that up just now.
Just now, right here, in the lobby of the Spring Hill Suites in Elmhurst, Illinois.
That's right. And of course, here you see our resident host here, Mr. Bruce Campbell. A little dressed up more than we are right now. We're all in Hawaiian gear, takeaway after dark gear right now. And here we are again for part 5. All right. So what do you expect out of our class, right? This is our factory class online. So we took our factory class, which we actually just did last week. You guys, if you joined us last week, you saw us online at the factory. Individual class registrations, recordings. 23 hours time, you will get an email from us with the certificate of attendance and a link to watch the video again in case you dozed off in the middle of our class and you needed to come back and watch it again. All right. And of course, there is still prizes for participation. All right. Asking good questions tonight. All right. Don't even bring up PDBs. Right. You do, you get booted. Right. I've only booted bots.
Yeah,
get bots in there. We've never booted anybody from here, but there's always a first time. Don't get John started. Of course, we have a lot of fun doing this stuff.
You don't want me having a meltdown tonight on a Wednesday night. It's just not pretty. Yeah.
So a little different than our Takeo Tuesday classes, right? We've got that after dark vibe going on right now, right? All right. So tonight's crapola. All right. I just realized I forgot to change some text on here, so I am going to apologize right now. All right, to my big guy over here sitting on my right hand side. All right, I did not include his name in here. I left Rick's name in there. All right, so yes, our theme for tonight is again, we're still sticking with that power trio, right? And we got ZZ Top coming into play tonight, right? So
I think you should have had Rick as the drummer, the guy with no beard. I think that would have been funny.
That would have been funnier. Yeah. This is just left over from last year. The text, I forgot to change the text on here. So when I was building this out, so damn, sorry, Jason.
And we never apologize for ZZ Top, says
No, true that. Yep. So it's been a busy couple of days here. So it's almost a miracle that we're actually here.
Yeah, we squeezed a lot in these 2 days.
Yeah,
a lot of training and a lot of other extracurriculars.
Yep. A lot of talking for the last couple of days out there.
Get yourself some cheap sunglasses, says Patrick. That's right.
All right. So again, that final debate, circulators versus zone valves out there. Let's talk about it. Which way is better? And you know what? It is summed up in one slide. All right. That we'll get to.
You know what? I can't see this.
Yeah, you can't. I know the sunglasses can't read it, can't see the screen. Exactly. I know. I've tried it in the past. It doesn't work, right? So you'll see this battle will go back and forth. And we used to see this often. All right. That, those with zone valves were better systems, right? And those that were zone pumps, you're antiquated out there.
Worse.
And when I first got involved in the industry and doing tech support and design, I used to design all my system with zone valves, right? And that was just me. That was my personal preference because I was also doing a lot of radiant, low flow systems, and I knew how big that circulator was, right? And I had guys walk in the door and say, "Oh, you got to redesign that entire project for me. Zone valves suck." And that's what I got, right? Zone valves suck, and I actually, what I also heard was, plumbers do zone valves, heating guys do pumps, right? And it was just like, wait a minute. Where I lived on Long Island, the plumbing and heating guys were the same guy. Yeah. So I was just like, okay, I'm not sure about that. So these battles and fights could happen all the time on which way was going to be better. All right. So, we don't need to battle it out in the parking lot anymore on which way is going to be better, right? So I love this picture, John. You know, the only thing you needed more in here would have been a lightsaber.
Yeah, there you go. Yeah.
We needed a lightsaber in there, and then yeah, we'll make that a semi-true story. All right, on battling it out in the parking lot on which way is better out there. All right, it's almost like, you know, 3 o'clock in high school, you know, in the basketball court. You know, we're gonna have a rumble.
We're gonna have a
You know,
rumble.
we're gonna have a rumble in the high school parking lot. So no, you know what? There is no one way better than the other. All right. The thing is that we're zoning. That's the biggest thing that's going on out there, right? So if I don't think anybody's keeping score. We're not keeping score on which way is going to be better, because what you got right now is somebody asking for zones. And what's a customer looking for in a house?
Control.
Comfort.
Comfort. Well, were they comfortable with one?
To the best of their knowledge.
Right, exactly,
Yeah,
right. So that,
their
you know, so
knowledge.
saying that they want comfort is difficult to say.
They don't know.
They don't know. They think
no
they're
idea.
comfortable,
Yeah.
right? Hey, a lot of people think they're comfortable with forced air. They just don't know.
Yeah,
right.
That's right.
You know, so it's depends on how you keep score on which way is going to be better out there. But the biggest thing when somebody's asking for a zone system, yes, as Jason said, they want more control over their house. All right. Their only interface to the stuff that we do downstairs is that thing on the wall. All right. They have no idea what's going on downstairs. And I know everybody online with us, if you've gotten a phone call from a homeowner and says, hey, can you come over and take a look at my furnace? And you show up at the house and you go downstairs and you look at a boiler. Right? Again, you know, our customers don't typically know what's going on downstairs. All right.
I don't know if you realize this, there's a lot of rats behind you.
I can't see a thing. All right. We got
Ratatouille
a good
movie.
Oh, Ratatouille's on tonight? Yeah. Okay. All right. So is that what everybody's commenting right now?
No,
too?
I just noticed
you just noticed it. Yeah. Okay. So, but in reality, when we start thinking about which way is going to be better, all right, there is no right way. Right. There's 2 ways to go, and that's your own personal choice and preference on what you're going to go here. Again, you're giving somebody more control. You're giving them comfort. You're giving them efficiency. Right. We have a lot more things that we can do by adding more zones in the house.
I've yet to see a homeowner say, I want you to zone by circulator and not that zone valve stuff.
Right.
I've never heard a homeowner express preference one way or the other because they don't know.
Right. You ask a homeowner, how many zones would you like? You get deer in the headlight look.
Yeah.
Right. What do you mean? I can have choices.
Yeah.
All right. And if you're
What
building new, yes,
what do you mean
got
zone?
choices.
What's a zone?
Right.
Yeah.
And simple funny story is that when I added zones to my in-laws got an apartment on my house, and I gave them 3 zones. They came from a 1,900 square foot colonial with 1, with a thermostat in the foyer. Which room was comfortable?
The foyer.
Nope.
Oh yes.
The home office. And why was the home office comfortable?
That's where Dad was.
That's where my father-in-law worked. And he had a space heater under the desk. So when I was dating his daughter, we'd be freezing our ass off in the house. And of course, I'm in the heating bit. So I go over and touch the thermostat. And all of a sudden he comes out of the office. Who touched the thermostat? What's going on? It's because now it got really hot in his office.
Yeah.
Right. So because we've been freezing, you know, in the house all day long. All right. So, but there are differences. There are differences between, you know, zone by zone pumps and zone by zone valves out there. All right. And understanding how to choose the right one for the application, that becomes the important part. So the big question out there, why, for those of you that said, why zone with circuits, why do you zone with circs? All right. What was your reason for when we asked you that before? What, now the answer to that question is, why would you zone by circ? All right. If you were going to set the rules of the land, what would you say?
Yeah.
You know, because now you need to have some sort of reason behind it as well, right? You can't just say, well, it is, you know, you got to have some sort of good reason on behind it. Okay. I think the biggest thing on why zone with circulators is why not, man? Right. We want zones, and you know what? If we didn't have any, we had 1 zone in the house, you still need 1 circulator. So if you wanted to continue that zoning, just repeat what you did. That's the beauty of hydronics. It's repeatable and scalable.
This is the way I learned how to do it. It just, by golly, the way I'm going to do it.
Exactly.
Right? There's
right.
a lot of that deeply entrenched.
It's what I've always done that way, right? And
My dad taught me how to do it.
Yep. Drop another circulator on right next to the other one. Okay. So circs, as we know, are darn reliable. Right? They are darn reliable. So by doing that, you know what you're getting out of it before. All right. Every system always has at least 1 circ on there. It does also offer that level of redundancy that people are looking for, all right, especially us installers. A lot of us installers and a lot of service guys like the redundancy. If I had, 3 zone valves in the house and 1 pump and that pump fails, I got no heat in the entire house. All right, I understand that, right? So therefore, if I had 3 pumps in there and 1 pump goes down, I still have heat in 2 other zones. 100% agree on that, all right? However, there are other things to think about on why you think that, okay? And we'll talk about that. And of course, the biggest thing is I look at the 007, the 007E as a BAP.
Big ass pump.
Big ass pump.
Big ass pump.
Nobody thinks it's a big ass pump because it is one of the smallest in performance circulators out there.
That's like this.
Yeah. We haven't gone that small yet. Exactly. Yep. That's a 1.5 watt circulator, right? Yeah. So what it's really hard to undersize when you zone by circulators. Therefore, and I get it too, because we also don't always, you've been joining us for 5 weeks so far. We're big on doing the math.
Mhm.
All right. However, you zone by circ, can you get away without doing the math? Yes.
Yeah.
You can.
Yeah.
All right. And get the job done and move along. We don't recommend that. All right.
No.
Because there might be better choices and other circulators to choose with. That's not tonight's session. This is just to talk about which way to pick a zoning system. Right. So therefore, those guys that said zone valves, why did you choose zone valves?
Yeah, it's for the zone valve guys. Yeah, give us the reason. Why
Yeah,
did you
what was
choose
your
that
reason
instead
for
of
zoning by zone valve?
circulators?
Yeah, say cheaper.
Yep.
Or cost effective.
Mhm. So we had a couple guys out there that said zone valves. I say, about half of you, all right, that suggested zone valves was your preferred method to go. Why did you choose it?
Yeah. Type that in, folks.
Yep.
Type that in.
Don't be afraid.
Don't be
All right.
afraid. While you're typing, we had a question. Can we use different size pumps on the same system? Oh, absolutely.
Oh, heck yeah.
Absolutely. Absolutely. You surely can. You surely can. And if you're using 3-speed pumps, they all don't have to be at the same speed. They can be at the speed that they're supposed to be at.
Mm-hmm. Yep.
And then
Yep.
Ivan, I'm going to hang on to your question for a little bit. I love your question. We're going to hang on to that one for a little bit. I promise you we'll answer it, but we're going to wait.
Awesome.
We're still waiting for the rest of you crazy kids out there to type in, why do you choose zone valves? And there will be no mockery of your
None
answers.
whatsoever.
None
All
whatsoever.
right. Because as you saw already, there was no one way better than the other. Right.
Yeah.
We said take your pick.
There you
But
go.
now you've got your reasons and you got your choices on what you got going on. Right.
Here we go.
So
Ahmed says to reduce the water flow, then we can select VFD pump to reduce the operating pump costs. Absolutely.
taking advantage of variable speed pumps.
Yeah, you
right?
start, and that's small residential systems up to larger commercial systems. Absolutely. McGrath, of course, King Richard I comes in and says, because I said so. Love you, man.
All right. So the big thing on why zone valves is, again, why not? Why not zone by zone valves? All right. They are reliable. Now, I said earlier today, when I started, doing this 30 years ago, and guys would come in my office and say, hey, zone valves suck. Guess what? Zone valves did suck at one time. I had to do some research. I had to find out why, because it wasn't just one guy. It wasn't 2 guys. It was quite a few of them 25, 30 years ago said zone valve sucks. And if anybody here has touched or looked at or done anything with a system that had a really old valve on it, what did you do with that valve?
Are you asking the group or are you asking?
Everybody online. Yeah. And here, right?
Don't touch it.
Yeah. You don't look at it. You don't even breathe near it, right? Because you get that really old valve, 30, 40-year-old valve. You don't touch it because then it's never going to seal or it's never going to open.
Yeah.
Right. You go to try to close it and then all of a sudden you try to open it and it's not going to open.
You
right?
break it, you own it, fella.
So you stop and think about some of those old valves. And I read some of the instruction manuals from the old manufacturers out there, and they suggested putting the zone valves on the return side of the boiler because of the way the valve was designed. It had packing, right? And you had a packing nut sitting on top. So why did they ask to put it on the return side? Oh, because it would be closer to the floor so the water didn't have far to go. No, I'm kidding. You like that one, right? I just made that one up just now too, because John's heard a lot of them from me over the years too.
I've been with you for too many days in a row, I'm telling you.
It was about seeing cooler water, because back then boilers were boilers, right? They were running 200, 210, right? So they said, oh, well, if we have that valve exposed to cooler water, therefore it's not going to leak as much. All right. And then when you go to tighten packing down, how much do you tighten it? When it is dripping through the stem, just enough. What's just enough so it doesn't leak? But if you tighten it too much, then you can't turn the valve, right? And then if you tighten it too much, then it screws everything up later on that packing and things like that. So the reliability was not there. And of course, us manufacturers that make a zone valve are not going to repeat the past. We make things better. All right.
There has been some ongoing PTSD in the radiant hydraulic world. If you've been in the game long enough, you've got some bad motorized ball valves or actuators out there. You've got zone valves.
Yep.
Then you've got pen runs from different manufacturers.
Yep.
So you go. It almost makes you lean towards zone circulator because you had such a hard time with valve.
Right.
But that's in the past.
Exactly right. Yep. Now, when you start thinking about zone valves, now we're looking at low voltage wiring compared to line voltage wiring. And wiring is one of those things that, you know, some people don't want to do or have to get somebody else in. And the maintenance on these things is a heck of a lot easier. So if you do have something fail in a zone valve, a lot of times it's just replacing the power head. All right, you can replace the power head. You don't have to drain a drop of water, because we've all gone to a job site where all of a sudden we've got a dead circulator without a valve in sight. Right? The only valve you have is the drain valve. Right? So we're taking a lot of water out of that system in order to change the circulator out. So here it's a lot of times just pulling out a power head. And of course, here's the biggest thing. All right, when you take a look at how much space you need for a mechanical room nowadays, our boiler rooms are getting smaller and smaller. Right, we're getting asked to put boiler rooms underneath the staircase. 30 years ago, as you walk down to a basement, you had a wall. Pick the wall, whichever one. Wherever the chimney is, go.
Take up as much room as you need.
Right, you got the whole wall. Now we say, hey, can you shove it underneath the staircase? You know, because we always need to. Well, we want to finish off that basement because we need to have a man cave, right?
Oh,
you
yeah.
know, and then we got to have a playroom for the kids. You know, and then we got someplace else in the house for mom to go to. So we always talk about wanting to spend more time together as a family.
No,
we all go home and disperse.
Yeah.
Right.
We're together.
Right. We're in the same house. If you've ever texted somebody in the same house you're in, all right.
Yeah.
You know, we all do it, right? Oh yeah. That's what we do.
That's what we do.
You know, I do it all the time to my wife. Where are you? I don't know where you are in this house. You know, and it's not that big of a house.
That's kind of the deal. That's kind of
Yep.
Got some questions. You want to jump on in?
All right, sure, definitely.
This is a good time for Ivan's question. He asked, does zoning with zone valves use less power, use less electricity? Absolutely, by exponentially. One circulator and 5 Taco Zone Sentry zone valves will use 80% less electricity than 5 circulators. And the magic math behind that is 1 circulator is 80% fewer circulators than 5 circulators. So the cost of electrical consumption should also be factored into your efficiency, overall system efficiency. So using the right circulator and zone valves, now you're getting your expense to heat the house down to a minimum. I've told customers, you know, that say I install the most efficient systems known to man, and I zone with circulators. It says those two are mutually exclusive. They cannot go together. You know, they just simply can't.
Right.
You can design the most efficient system possible while zoning with circulators, but it's not the most efficient system possible because of the electrical costs associated.
When we look at a 007, which is by far the most common circulator used out there, is 80 watts. We take the 0015, our 3-speed, it's 85 watts. We jump to our ECM line, maximum consumption is 44.
Usually,
more common is around 12 to 20.
Yeah.
Right. So we're looking at very low consumption there when we start looking at those circulators, but still a zone valve like the ones you see here in this picture pulls 1.5 watts. All right. So if I can zone with 1.5 watts compared to 80 watts, then we're looking at some savings. All right.
The 5-zone system, you're talking about 86, 87 watts versus 300.
Right. Yeah. I mean, John and I have done the math before where we look at it. I think it's a savings of almost $130 a year in electrical costs.
Can be.
Yeah, up to that.
You know, with 5 pumps
versus 5 zone valves. Yeah, definitely.
A couple other questions or comment. I've only noticed my company using zone valves on radiant floor heating and circs on larger zones like radiation or baseboard. I'm not too sure, to be honest. That's a way to do it, but again, it really probably doesn't matter. really which way you do it. A couple of other questions here. I have found some zone valve systems that were done and didn't have the correct pump, and it washed the bodies and leaked by. So basically blow by.
Blow by, too big of a pump.
Too big of a pump. Lot of sizing a circulator with zone valves is really simple, and it's so easy to get wrong. People think it's all that head loss, I got to have a super high head circulator, and you don't. You don't. It's a parallel piping. You just have to overcome the worst case head loss zone and not worry about all the others. Because if I can overcome 6 feet ahead, I sure as heck can overcome 5 feet ahead, right?
And we're going to do some of that math tonight.
Excellent. Yep. So I'll shutting up.
No, it's all good. It's all good, right?
Very good.
So yeah, and you know what? We pulled some of these. This is an older number here that I pulled up. That 3007s cost about $90 a heating season for 3 pumps. Again, not bad. You know, this was a couple years ago when we did that math. I'm looking at today more like, you know, what electrical costs today, especially for me on Long Island, I'd be looking at almost $180. You know, almost double that number right now. So, but like John was saying, 1007 and 3 zone sentries, we're getting down to $32, right? Very, you know, right there on a 3 zone system, you're saving $60 a winter. Okay. So, but I know about the redundancy conversation, all right, on your zone pump guys out there, right, that want a zone by circulator, and looking at that redundancy is a good thing. Yes, I agree. All right. However, when the pump fails, you have no heat, right? Like we said before, circs are darn more reliable, right? They are very darn reliable, but you're still showing up. The homeowners are going to call. If you had 3 pumps in the house and one goes down, they're still going to call you. And what's on your truck? Do you have a spare pump? Most people will have a spare pump when they go to the job site. All right, so you're going to have that spare. And here's also something else that I learned. So I spent some time with the engineers upstairs at Take when I first got here, and I said, picked up a pump, and I said, how long is this going to last? And I was expecting this years out of it, right? This number out of it, and they turned around and said 250,000 cycles. And I said, that's useless for me in a training class. I said, you got to give me something more there. And they said, well, when we design the circulator with the materials that we have and the bearings and all this other stuff that we have, we design it to last 250,000 times to turn on and off. And that equates to 18 years in a 1 zone house.
Minimum.
1 zone house. All right. That's sort of our minimum threshold is designing that circulator. Yeah, we can design a circ that would have a minimum of 500 cycles, 500,000 cycles.
Get your checkbook out.
Exactly. Right. So we're not going to do that because we do, you know, it starts to price itself out. All right. And being any value to people out there. So, so 250,000 cycles, but now think about this. How many zones is normal in a house today? Yeah, there is no such thing as normal, right? I mean, I put 7 zones in my house. All right.
You guys
I know some people.
You guys have been watching Takeo After Dark for a long time. You should know better than anybody. There's no such thing as normal. Hey,
Pretty close.
And you're new.
That's perfect. Sorry.
You're
Yeah,
new.
okay. All right.
You're new. We still have time to ruin you.
He's got a nickname, Abby Normal. Yeah.
Abby somebody.
Right. So when you think about this for a second, so now you got a zone valve system, okay? And when the circulator turns on, let's say, you know, all zones are off, zone 1 turns on, turns the pump on. Zone 2 turns on. Look at the pump. It's still running. You eliminated the cycle count. Zone number 3 turns on. Zone number 1 shuts off. All right. Being a New Yorker, zone 3 doesn't shut off right now. All right. We're online. We're online right now. All right. So you see your cycle count actually goes down. So when people say, hey, I see circulators fail all the time, all right, because we're hitting that cycle count much faster than we have in the past.
He's cooking.
Okay, all right. I wasn't sure if you guys were looking at me or watching TV.
Oh, watching. We're watching the movie.
Yeah. Oh. So that's what I'm thinking about when it comes to, you know, you want that circulator to last a long time, minimum cycles. All right. You're going to get a long life out of it, right? How long does it need to last? Do I need it to last 40, 50 years? Or do I need it to last as long as the boiler? right, in the system that you have in that house at the same time, right? We don't want it to fail prematurely. And I know those of you out there that are in the service side of things, you're going to say, hey, man, that's job security, right?
You're going to tell the customer that when you put it in.
Exactly.
Yeah.
Yeah.
If
So-
you're not going to, then don't do it.
Then don't say it. Yeah,
Don't-
that's
don't
not,
do it,
that's
don't
not a
think
good
it.
reason, right? Exactly. So, all right, we have hit, wow, perfectly midpoint of the show tonight.
You are on fire, brother.
All right, so our Takeo trivia of the night, all right, dealing with ZZ Top here tonight. All right, as we think about this trio here and of the 80s and 90s and even 70s as well. I mean, these guys were around for a long and still playing. I mean, not as a power trio any longer, unfortunately. No, one passed.
Okay.
All right, who was it? Dusty Rhodes passed a couple years ago. Yep. So ZZ Top's music and videos have been played all over the place on radio and TV. However, they were in a movie. All three of them together were in a movie in the 90s. All right. What movie did they play in? All right, where you actually saw all three of them with their instruments. All right. So type that in there tonight. All right. And we've got our, of course, we have our special Takeaway After Dark giveaway stuff. We do have a backpack cooler. All right. So I have that going on. I do also have some Takeaway After Dark t-shirts as well. All right. To get out there. So John's going to be recording all the names, throwing it into the Wheel of Death. All right. And we'll be raffling that off at the end of class tonight. Those of you that joined us last week, no, I did not get shirts out from last week. I haven't been home. All right. And, but I did get everything out from episodes 1 through 3. All right. So if you guys were expecting something, you should have gotten it by now, maybe except for 1 or 2 of the guys up in Alaska. All right. So if we have some of our guys from Alaska, if you didn't get it yet, it's on its way. So let me know if any of you guys that had something coming to you, let me know if you got it tonight. All right. Type it in there if you can. All right. So we'll keep this going to the end. So, all right, let's use sharp dressed men. Let's get back on the road now, shall we? And that was one of my favorites, right? That keep on going. All right, so circ sizing. All right, for zone valves. This is where it really, like we talked about before, zoning by pumps, really hard to undersize. You're going to have more than enough pump, especially if you pipe in 3/4 inch, right, for most of our zones, which, as we learned a couple of weeks ago, 3/4 inch pipe's going to get you 4 gallons a minute, 40,000 BTUs, 72 feet of baseboard, a crap ton of heat. All right, so you throw a circulator on that, you're going to have more than enough out there. Okay, so sizing circs for zone valve systems out there. All right, what you need to know is one, the total flow of the system. So you need to know the gallons per minute for each zone. All right, and up until tonight, we've shown you how to do that math, break out your universal hydronics formula. All right, catch it up to the heat load of the zone itself. Then we need to figure out the head loss of every zone. All right, that length of pipe. So what you're doing is, and we've shown you the quick ways, which is based upon the length. As we said last week, that's probably going to be about 40% too much head out in the system itself. So each zone, you find the flow and head for each one. Okay. And then what you need to do is you add up all the gallons per minute. All right. And then find the highest head, because yes, our GPM is cumulative from each zone. So we need to add it up, because there will be an instance all 3 zones can call at the same time. So I need to make sure I have enough gallons per minute. That's our BTUs. That's our heat. All right. But head loss is not cumulative. All right. It is not cumulative. Head loss here is find the highest. Because if you can satisfy a zone with a low head, a high head, you can satisfy low head. All right, I'm gonna break up the screen up here for a second. All right, and I want you guys over the weekend to do some homework. Do some homework. Everybody, not you guys. Everybody online. No. Everybody online is going to do some homework. Now, what I want you to do is go outside your house. All right, and outside your house, you're going to have a water spigot. Take out your hose, run it out in the yard, and run it to the first tree or fence post and mount that hose 5 feet high. Turn on the valve slowly until the water just starts to trickle out of the top of the hose. You can all imagine that, right? So all of a sudden the water just comes up to the top and just pours down the side of the hose. Okay. Now, that's not the freaky part that I want you to do this weekend. This already sounds weird. This already seems weird. All right. What I want you to do now is take this perfectly good hose and go get a knife and cut the hose and add a T to it. And now take a piece of hose and run it to the next tree or fence post and mount it 7 feet high in the air. Now, based upon the valve position to satisfy 5 foot, what's happening at the 7 foot? Do we have water coming out? I didn't change the valve. All I did is just cut the hose and mounted it 7 feet high now. I got no water coming out, nothing. All right, so you start to increase the opening of the valve itself. As you're opening that valve, remember this isn't a ball valve, right? Once you open that valve some more to get the water to crest out of the 7 footer, what's happening at the 5 footer? Is it just cresting out or is it coming out a little higher? Right? It's going to shoot up a little bit more. Do it again. All right. So here's the point. If I can satisfy 9 foot ahead, I can definitely satisfy 7 foot ahead, and I can easily do 5 foot ahead. But as I was opening the valve, I increased my GPM. So as my gallons per minute went up, all right, I was also increasing my head, the pressure that can come out of, because that's the dynamics of our plumbing system. This is your hydronic system. When you're zoning a system by zone valves, you add up the gallons per minute from each zone, but then size it based upon the highest. Does that make sense to everybody out there? All right. So anyway, so that's your best way to think about how you find your flow and head in a hydronic system with zone valves. All right. So let's say we've got a total heat and load for our project, as we guys showed you already, 75,000 BTUs. My flow rate is, what do we need? What do we need? I think some people can answer this math really fast, all right, without breaking out the calculator.
What you get, 75,000 BTUs, GPM equals BTUH divided by delta T times 500. Douglas spec has it, 7.5 GPM.
He's got it, 7.5 GPM. That's
Riley's
what we need
got it.
all day long.
McGrath says he's not answering.
Okay, thank you, Rich. All right, because he, so now we're going to measure that longest run and find the highest head. So that is going to be all of the pipe associated to the circulator out through the zone, count the baseboard. All right, that's also pipe in there as well, coming all the way back and through the boiler back to the suction side of the circulator. And again, as we said last week, estimate this number. It should end in a 5 or a 0, rock and roll from there. All right, so, but now we look at the flow rate of that zone that happens to be the longest, that has the highest head. 3 gallons a minute was my flow rate. The length of the zone was 140 feet. All right, so multiply that by 1.5, we get 210 feet of equivalent length. All right, so that's our equivalent length that we have. And now we come to, and this is going to get us a little bit closer. All right, we showed you the second way without doing that 40% oversizing by taking that number and multiplying it by 0.04. We're going to get closer. So know your pipe that you have, our gallons per minute. We got 3/4 inch. We got 0.009 is the pressure drop in PSI per foot of pipe. Multiply that by 210, I get 1.9 PSI. We convert that to foot of head, and now we do that conversion. 1 PSI equals 2.3 foot of head loss. All right. And yep. So we get our approximate head of 4.5 foot ahead. That's getting us pretty darn close, but still oversizing. So don't be afraid of this number. All right. It's still oversizing because we estimated that length and then we added 50% more for all the fittings that you can't see out there. All right. So it is still going to be on the safe side. So we're going to need a circulator that can move 7.5 gallons per minute and deliver 4.5 foot ahead. That's our size. Wow. That's it for a 3-zone system, 75,000 BTUs. That's all we need. That's it. All right. It is not a monstrous pump here for 3 zones. I know people all of a sudden they see 3 zones and they say, oh, you got to have a bigger pump on there, or you got to have a 3-speed set on high. You
got to push that water through all 3 of those zones.
Push it through.
It's a long way.
So let's take a look at the 3 speeds. All right. take a look. Where do you put, what speed would you guys run the circulator? So this chart's showing us our 2 3-speeds that we have, AC circs, not the variable speeds. These are just 3 settings, all right, 3 speeds. You got low, medium, and high. You got the 0015, which is a very common residential pump. And then we have the 0010 3-speed pump. All right, so what you want to do is plot out what you know. You know your flow at the bottom at 7 gallons a minute. We see our head over on the left-hand side, and bango zumbo, there you are. That's what you need. So what speed would you set the circulator for? All right, if we're looking at the 0015, what speed would you do it? All right, I know a lot of people would look at it and say, well, no, you need medium. You need medium because it's above the curve.
Right.
It's above the low speed. Probably want to be on the safe side and put it at medium. But remember, we estimated our head loss. All right, so our head loss is estimated here. And also that flow rate was based upon what? What was the big thing that my flow rate was based on?
Coldest day of the year, baby.
Coldest day of the year and a 20-degree delta.
Yeah.
If I would have put this pump on low and I was at a design condition, all right, I'm not going to get a 20-degree delta. I'm going to get something less like, oh my goodness, 22 degrees. I might see maybe 23, all right? You're still going to be delivering the heat to the house itself, all right? So you can easily operate it on low all day. But if you were to go ahead and start increasing, you can see what our different gallons per minute, what that head loss is. And if you were on, set it on high, all right? If we take that circ, set it on high, you're going to deliver almost 11 gallons a minute. And it is also going to deliver just about 10 foot ahead. We only needed 4.5 foot ahead. All right. But now all of a sudden we are way over pumping the system out there. Way over pumping. All right. Well, what if we go ahead and go after the variable speed circulators like our 0015 E3? All right, when you look at this circulator here, the 3 settings that you have, low, medium, and high, low and medium becomes our variable speed circulator. When you set this circulator on high, it's fixed speed, full out, give me everything you got. So when you are doing a zone valve system, we want this circ in low and medium always. If you're doing a zone pump system, we want this in low and medium always. The only time I really put this circulator on high is for an indirect tank or for a boiler pump. All right, that's the times I use it on high. Even if it was a zone pump system, I'm still going to be in low and medium. So we take a look at our project today, 7.5 gallons a minute, 4.5 foot ahead. It's going on low all day.
That's going to be the perfect, that's the perfect circulator for that job.
It is. This is the perfect circ and the perfect setting for it too, because now it will slow down. Remember, this point is when all 3 zones are calling at the same time. All right, yes, that's what we need to design the circulator for. But again, how many times are all 3 zones going to be running at the exact same time? If we were to set this, sorry. So that's where we're going to see. But this is our pump curve that we're going to, whoops, sorry. Trying to work around a microphone here. That's for all 3 zones running. All right. Now this line out here, it would be 44 watts. So if I would have set it at medium or high, it's going to give you full power 44 watts. By setting it over here, yeah, we're going to over pump just a little bit, not a heck of a lot. All right, maybe a half a gallon a minute, but this is going to operate at maybe 30. And then when we have our other zones on it that close down, all right, this will now become a variable speed pump and slow down as my zone valves open and close. All right, or mostly when they close. All right, when it's and they open, they'll speed back up again, and it'll bop across those different system curves that you have out there. And you can see if we get down to a smaller zone, like the one that we did calculate, 3 gallons a minute, 4.5 foot ahead. That's our design that we started off with, but we added the gallons to get us all the way out here. All right, now you're looking at a circulator running 10 watts, maybe 12.
And think if you just set that to medium instead of low, the system's still going to work. You're still going to get heat, but you're farther away from your requirement. The delta T is going to get smaller, and it's going to vary at speed. It's all going to work, but your delta T's are going to be smaller than they would be if you took the time and set it up properly. And the smaller delta T's just don't help system efficiency.
Yep, definitely.
Question here is, how would you use a constant pressure pump on a zone valve system? Asks Alexander Sharp. I think this is just the example, right? This is the constant pressure pump right here, Alexander. This is, you select your constant pressure line that best fits the highest head loss loop, And that's kind of the way you would set that up. So exactly what you're seeing right here.
All right, so constant discharge pressure, flat curve pumps, that's what you want to see with zone valve systems. It also makes the noise go away.
Mhm.
All right, when you have quick closing zone valves that slam shut, we get noises that can occur. All right, but let's take a look at a little bit further into our system here. Let's take a look at that smallest zone that we have, 20,000 BTUs. All right, oh, I got a typo here. All right, we got 1 gallon a minute typed in. There should be 2, or maybe I got 10,000. I can't remember the math right now in my head. All right, you got the length of pipe here at 120 feet of pipe. All right, multiply that by 0.04. All right, based upon the chart that we're looking at here. All right, let's see which chart. This is 2 gallons a minute, correct? Yep. So that's the typo up there. 0.004 psi. All right, gets us 0.48 psi. 0.48 times 2.3, or 1.1 foot ahead. 2 gallons a minute, 20,000 BTUs. That's still a decent sized zone, but it's going to have 3/4 inch copper on it, right? Because we don't typically we could get away with 1/2 inch, and I've seen 1/2 inch baseboard. They just don't install much of it, right? We do everything 3/4 inch. So therefore, when you go with 3/4 inch and you only need 2 gallons a minute, it's very easy to move that water through. So the resistance is not as hard. All right. So now we're looking at 2 gallons a minute at 1.1 foot ahead. We come over to our 3-speed chart and look at that. By that zone by itself, low is still way too much pump. We take a look at that pump curve. All right. We come up here. You're flowing 6 gallons a minute. You just tripled the flow through that zone. You tripled the flow through that zone, right? So yes. All right. When we start looking at these pumps, they get bigger and bigger when we start multi-zoning these systems out there. All right. And if we take that 3-speed and put it on high, we'd be looking again. We're looking at 7 gallons a minute almost. But hey, it's a zone valve system. I got to put it on high. Right. Right. Yeah. You got a Delta T that's about like 3. Right. The water's
Under design conditions.
yeah, the water's screaming through that system whether it wants to or not. Right. So it's challenging, man. Right. Now let's go ahead and take a look at ECM 3-speed, 3 setting. Right. 2 gallons a minute, 1.1 foot ahead. All right. Yeah, we're going to be over pumping here, but we're not at 7 gallons a minute. All right. We're going to be about 4.5, but we don't have any other choices on this one. Right. Again, we can get better. All right. There are ways that we can get better with other circulators out there. Yeah. All right. And again, this is where we were before. All right. This is the full project, way out 7.5 at 4.5. So, it's going to be, operating again. This is one zone here. This is all the zones out there. Okay. Now here's another circulator to take a look at. This is our Delta T circulator, VT2218. This one varies its speed based upon the temperature drop. So it's going to maintain that 20-degree delta that we wanted it to, whether you have zone pumps or zone valves. So now with a zone valve system, it will speed up and down like the 0015, which is our pressure differential pump. But now this one speeds up and down differently based upon zone valves that are opened and closed, as well as the temperature changes outside. It sees a larger demand, the circulator speeds up. It sees less demand, it gets warmer outside, I need less. Under design conditions, 7.5 gallons a minute, 4.5 foot ahead, bang. That's where we're operating at full speed. And now you see this yellow line is going to be on new performance curve of the circulator. All right, and you draw out your system curve, and that's what we're going to have. Now you could have all 3 zones running on a design day. That's where we're going to see a 20-degree delta. Then all of a sudden, if we warm up outside, all 3 zones are still running, it's going to slow down. All right, until you get to the minimum. All right, so we still have a minimum that pump is going to run at. Now that 1.1 gallon a minute, that's small. 2 gallons a minute, 1.1 foot ahead. All right, it is going to be operating still over pumping, but we're looking at less than 1 GPM. All right, because this circulator does have a minimum speed. You can't go any slower than slow for this circulator. All right, so we have that minimum that we need to. Now, as a zone pump, and you only had 2 gallons a minute at 1.1 foot ahead, this Delta T pump is not the ideal. It's a big ass pump. All right, it's always going to operate on curve A at the lowest speed. Again, not horrible. You've got a 9-watt circulator heating your house. All right, so it's the minimum, but you don't have any of the variable speediness that you can get out of a circulator as if you were out here at that 7.5, because now it will speed up and down here and here. But as your zones get smaller and smaller as a zone pump, maybe not a great idea because you're not going to see a lot of changes, right? All right, now let's say we're getting bigger projects out there, all right, because 75,000, nobody has 75,000 BTU systems. That's tiny, right? That's like a shack around the corner. No, we're going 120,000 BTUs out there. 12 gallons a minute, each zone 40,000. We're pushing it, right? 3/4 inch pipe. We got 200 feet each. Hey, we wanted to make sure we get each one of those lengths relatively close to each other out there. So we do the math at 3 PSI. All right, 7 foot ahead, 12 gallons a minute total, each one being 4. All right, so we got 12 GPM, 7 foot ahead out there. 12 gallons a minute, 12 gallons a minute, 7 foot ahead. We're still looking at a 0015 on high. Okay, so we still have more than enough pump out there. And that's when all zones are running and design day. We're looking at, it's cold out, every zone's on. It's a perfect alignment to the planets. All right, it's Christmas and New Year's and your birthday all rolled into one. All right, you can't ask for a better day, and that's almost the perfectly sized circulator for you, setting it on high. Okay, it's going to operate right there, really close to what you need it to do. Now we got one zone running 4 gallons a minute, 7 foot ahead. So now remember, all 3 of our zones were very close in size. All right, but it's going to operate way out there. You think it looks really good operating on low, all right, but it's going to be on high because you need it to satisfy the whole house. But now we're way up here. Okay, so that becomes a challenge there. The other thing that we have to look at here, let me erase the ink on this page. All right, I'm going to think about, anybody here run into noisy systems with zone valves, like banging zone valves that are installed correctly, that you didn't install the valve backwards? All right, a lot of zone valve manufacturers out there have an arrow printed on it, meaning which way the flow is supposed to go. The Zone Sentry that we have does not. All right, it is non-directional. It does have markings on the valve body that says A and B. That is not for our zone valves. All right, we use that for other applications.
It shares the valve body with another valve, right?
Correct. The casting is, yeah. So the casting, we have that marked as an A and B, but it is not a direction. So you can put it any way you want. All right. So has anybody run into banging zone valve systems that are noisy? All right. And the thing that happens, all right, that people have looked into is, where did that noise come from? And it's very hard to find in detail. Now, in a system like this that had 3 equal zones, you may not hear it. Oh, okay. I thought you were waving. No, I had to stop for something. Your banging occurs of the large pressure differential that you have in a system. As we talked about, this spot right here is the entire house running all 3 zones. Now, let's say you had 2 zones close instantly. Large pressure differential, what you end up doing is backing up the pump curve. And because a pump can only work on the performance curve that it has and the system curve that you created, it backs up to here. All right, it has to, because my flow dropped, right? We were flowing out here at 13 gallons a minute. Now we're flowing out here at 6 gallons a minute. But the problem is that we go from under 8 foot ahead to 14 foot ahead. Large pressure differential occurs and it bangs because the circulator doesn't slow down at this point. It's running the same speed at 3,450 RPM. It's just I can't flow as much because the valve's closed on me. So it has to back up the pump curve, and we see that bank from quick closing zone valves. We don't see that with our 570 series, our heat motor zone valves, because they're slow closing. They're also slow opening at the same time. How do we make that noise go away? Well, we make it go away by going to flat curve pumps. Something that's got a flat curve in there, like our 0015, the 007E, or the 0015 E3 as well. All right, is going to get you that flat curve on there. So as we look at our 12 gallons a minute at 7 foot ahead, yes, it falls outside the range of what that 0015 could do, low, medium, or high setting. All right, but again, like I said, we just have maybe a little bit more than a 20-degree delta T. Not a big deal, okay? But as we look at 4 gallons a minute, 7 foot ahead right here, all right, that's what each zone would be running at. And then if we double, we had the 8 gallons a minute, 7 foot ahead sitting right here, that's 2 zones running, all right? And now what we're going to do is we're going to set it in medium speed, all right? Now we could put it on low, but again, if we put it on medium, all right, medium speed is going to be operating out here and then over here. So you can see the pressure differential that we go from 7 foot ahead to 10 foot ahead. We're not seeing a large pressure differential here. That makes the noise go away. All right, and then you take advantage of the circulator speeding up and down as zone valves open and close. All right. All right, and now again, we take a look at our VT2218, 12 gallons a minute, 7 foot ahead. We're running almost full speed of that circulator. Zones start to close down. There's my 4 gallons a minute, 7 foot ahead, and then here's my 8 gallons a minute at 7 foot ahead. All right, so you can see that we'll just speed up and slow down. All right, again, this is all design conditions. As the conditions warm up outside, it goes even slower. All right, and starts consuming even less wattage. All right, as the season goes on, but still maintaining. Here's the biggest thing about Delta T. I love this pump for everything. All right, this pump now changes the dynamics in a house. It makes a house even more comfortable because it's always doing a slow and gentle heat into the space. You never get fast and furious. You don't hear the whooshing of water. You don't get the pinging. It's kind of matching the heat loss of the house by delivering what it needs. So that's the other side of sizing circulators, is actually making sure that we're not over pumping, because hydronic system wants to see slow and gentle.
Right.
Forced air is fast and furious. Right? We blast, and when you look at thermostats for forced air, they're designed to have a wide differential. Hydronic thermostats, short differential. We want to see longer on times and short off times. We're not using more BTUs. We're using the same BTU per hour. We just want to deliver it over 50 minutes rather than 10 minutes.
Right, and then wait and see what happens.
So forced air is designed to have that wide differential. You set it for 70, it doesn't turn off until it hits 72 in the room, but it doesn't turn back on until 68. Hydronic systems, we want to see a half a degree differential. Right, 70, turn off at 70 and a half, maybe 71, turn back on again at 69. Keep it tighter, a lot more. That's why everybody that says they have a hydronic system, you don't run into the overshoot, you don't get the flywheel effect, especially with a Delta T pump. All of that gets eliminated, right? Just making a system a heck of a lot better out there.
A couple questions. One of our guys, Ryan Moore, had never heard of the VT2218. I didn't know it existed. And he asked, does it have a sensor or something? So it has 2 sensors. It comes with 2 sensors, simple little 10K resistors. One is strapped onto the supply pipe as it's leaving the boiler, the highest water temperature going out to the system. And then a second sensor on the return, which is maybe on the common return. So these are my 4 returns for my 4 zones. You'd probably put it right here. So it's a common return temperature. And what it's doing is it's monitoring the difference in temperature between what's going out and what's coming back. It doesn't care what that temperature is. An awful lot of people say, well, it's going to fight with my outdoor reset, right? It's going to fight with my outdoor reset. Nah, it doesn't care. The outdoor reset's simply going to set the supply water temperature. The Delta T pump is going to simply monitor the difference between what's going out and what's coming back and changing the speed to maintain whatever the Delta T is you designed that system for.
Right.
Crazy concept, right? But it works. The U.S. Department of Energy says this is the most efficient way to run a variable speed circulator. So Ryan then followed up with, would this be considered a universal pump? I would struggle with that. It's close to it. I mean, it is the only circulator, for lack of a better word, that will size itself, provided you're in that wedge.
Mm-hmm.
Despite what all the other buttons and everything you push, this will size itself, provided you program it to the Delta T the system was designed for. So it's close to that. It's very, very close to that.
Right.
Well, there's a couple of reasons behind that, Jason. One is it is a very expensive circulator in its current form, because it's a multi-feature, multi-function kind of an oddball circulator in its manufacturing. I think coming next year, you're going to see something very, very interesting with some new product, a new product that we will be adding to the portfolio. It's going to make Delta T so much more accessible to many, many more people. So it's going to be very, very cool.
We may have a Takeo Tuesday on that sometime in November or December. That maybe emails went out already. I'm not sure. I think I saw a bunch of emails go out for Takeo Tuesday classes later this year. Yep.
Aren't you special? I like that, man. I like that.
So also where we talk about where this pump may not be the best pump is kind of what I was talking about before. Let's say this zone, this size here was your maximum for the entire project, right? And that's the design day. Give me everything you got. All right. It never goes higher than this. It never goes up there. This is the maximum. So therefore, this is all your variable speediness you have available to it going from here to here. So again, not horrible. Not horrible. But then when we look at a lot of systems that run at 4 gallons a minute, all right, and 4 foot ahead, kind of like what we were showing before, now this becomes your variable speediness. You only have, yeah. Right. So that's why I like this with zone valves, especially, right? And large zone pump systems. If you're out here as its total zone, all right, not a zone valve system, that's your zone pump, great, run there, man. And you take advantage of what this pump can do. So your little tiny zones, you're getting advantage of it, but not full advantage. Yeah. Right. All right. Wow. Look at that, JB. I can't believe that. Yeah. Wow. I know. I am 1 minute over right now. I am 1 minute over. So still type in any questions that you may have, whether it's anything about tonight's webinar, whether it was something about last week's webinar and the week before that. And if you're really good, if you've got questions about next week's webinar, still ask them. Okay. All right, so still ask those questions. We'll stay here. I mean, a lot of people have been walking by and checking into the hotel, and they keep looking at what we're doing over here by seeing the camera and the microphones and 3 of us hanging out here. They're like, what the heck is going on out here? So yeah, we'll stay online as long as you guys want us to. So anyway, so shall we close out our Takeo trivia of the night?
I think we shall. We got everybody else.
All right, so JB put everything into the spinning wheel of death.
Yeah, everything's in the spinning wheel of death.
Okay.
All right. Oh, I got to go back and get my.
You got to pull up the screen. So here, our trivia question of the night. All right. You know, like we talked about ZZ Top, and they were in one movie, all 3 of them together playing in a movie. And here is a clip from that movie. I just love the drum spinning here too at the same time, right? You know, because they always did the guitar spinning and stuff like that. So what the heck happened here?
I took the screen.
I didn't give the answer.
Oh, I'll give it back to you. I'll give it back to you then.
I just left everybody hanging there for a second.
I'm sorry.
JB just took the screen away from me.
I'm giving it back to you. Sorry to, because I wouldn't screw it up right now, apparently.
All right. So the answer is Back to the Future 3. Back to the Future 3 when they went back in the Westerns. All right. So,
I went everybody, just Back to the Future was good enough for me.
Awesome.
I'm a very generous.
A lot of good answers tonight. A lot of answers coming.
I'm a very generous guy. You know me.
All right. So Back to the Future 3. So yes. So those of you that answered, everybody has a chance to get into that Takeo After Dark backpack, and then of course a couple Takeo After Dark t-shirts.
May I take the screen now?
Now you can take it. Yes. Now we have the answer out there, everybody. Right. Oh wait! Don't take it yet. No, you did it already.
Start with me.
So one more thing.
Yeah, one more thing. Easy there, Columbo. All right, can you see me?
I can see the screen. Yes, sir.
All right, I'm gonna get this stuff out of the way, and this stuff out of the way. All right, and we'll make it
the icon right next to where it says gallery. It'll blow it up full screen.
I got full screen right there. So, are we ready for round 1? Let's hit this thing, right?
All right, who's writing them down?
Jason's
going to write them down for me. I didn't have anything. I didn't take a notebook out. Sorry about that, everybody.
First winner is, of course, ZZ Top's Accelerator.
All right.
Well, we're going to have to.
I get to keep the backpack for myself.
We're going to have to spin that one again, my friends. Let's do it one more time. And around she goes. And where she stops, Only David Cooper knows. David Cooper, congratulations, David. You are the winner of the Takeo After Dark backpack.
Awesome. Awesome. Thanks, buddy.
And we're removing you, David. You can't win anything else. Not
Okay.
tonight, anyway. Next week, we start fresh. All right.
All right.
T-shirts?
T-shirts time. T-shirt time.
T-shirt time.
Takeo After Dark T-shirts, which I don't have with me tonight. Takeo After Dark on the front. We got the family on the back, and we got the Takeo logo on the sleeve. JB's got his on. There it is.
Aaron Bruce. Congratulations, Aaron. Okay,
I believe
cool.
so.
You're getting a whole
Yep.
wardrobe there, brother.
If you want a different size, type it in there. If you got yours already and you want to give it out to your friends and family, whatever, let us know. Type it in the chat section so we'll know to
Okay,
get that out to you.
Doing? 3?
That was only one right there. So yeah, go for 2 more, man.
We got 2 more. All right, round and round it goes. Who could it be? Who could it be? It is Spencer Steckelberg. Spencer, how you
Excellent.
doing? Welcome. Glad to have you. And that says, I know that says Spenecker, and that's not you, but I was typing quickly. So my apologies, Spencer.
Yeah, it gets a little when we getting those answers in and trying to answer questions and everything, gets a little crazy doing that. So excellent. Thanks, Spencer.
Okay, one more T-shirt.
One more. Let's do it. Let's do it.
Oh, that looks like Patrick. No,
there
Patrick.
It is, Patrick inched it out. Inched it out. That's it.
Patrick, congratulations. Awesomeness. Sorry, Randy, man. It sometimes the magic works, sometimes it doesn't. What can we tell you, no? What can we tell you? All right, excellent. Very good. All right, I'm going to stop showing my screen. There we go. Get rid of you. I'll give it back to you, Dave.
All right. Well, I got nothing left to show right now tonight. I mean, I do have basically showing what we want to do for next week. Next week, now we figured out what zoning package you want to put, whether it's zone valves or zone pumps. Next week, we're going to talk about how you're going to control it. All right. How do you wire it in? How do you put it in there? And we're also going to talk about the new -5 controls that we have and what you can get out of those things as well. All right. So that's going to be, oh, wait a minute. I'm not going to be around.
No, you're not.
I am not around next week.
We will be in Seattle next week.
Uh-oh.
We're going to have to figure
We're
something out.
going to have to figure, I mean, I might be able to do it. I'm going to be at a trade show. So I'm going to be at a show in Atlantic City. So for those of you on the East Coast, all right, trade show next week, Eastern Energy Expo in Atlantic City. Now it ends Wednesday. All right, so I've got to take a look at my schedule and see what's going on and see if I can make that class. I'm going to have to figure it out.
All right, yeah, we'd love to.
Obviously, I'm going to have to be the one doing it since you guys will not be able to.
Yeah,
you're already doing a class.
Yeah, we're doing a class. Yeah,
but it's unfortunately it's not Takeo After Dark. It's Takeo in the afternoon.
Takeo after lunch in Seattle. Yeah.
All right, so I may be running solo next week.
All right.
Pulled over at the roadside.
Well, no, we'll be there. We'll be there.
Oh,
we'll be there. But you are the key presenter, man.
I am, yes.
On this particular topic. This is
True,
you are.
I am gonna have to find some place to pull over and do it. Yep. All right. We'll figure. Yeah, wherever I am. Yeah.
If you're in New Jersey, I'm sure you can find a diner somewhere where you can.
Yeah. I think I'll just have to stay in Atlantic City an extra night. So anyway, so next week is Eastern Energy Expo. All right, and next week I'm actually doing those 2 classes combined next week.
Oh, fun.
At the show. So I'm doing the zone valves versus zone pumps, as well as controls are built into that class as well next week. Yes. So that will be in the morning at the trade show on Tuesday between 11 and 12:30. So it's going to be a little condensed. It's not going to be the 2 full hours like we have for Takeo After Dark. So that's going to be next week's class. I'm also co-presenting with another OESP oil, the Organization of Oil and Energy Service Providers. We're doing a water quality class.
Oh, excellent.
Right. We're just going to be talking about water quality in there. And I'm doing that with a fellow partner in the group by the name of Jason Mangos. What's that? It is not online. It's a live class. It's only a live class and that's going to be on Wednesday morning before the trade show starts.
Be busy Wednesday.
Yeah, you're going to be busy on Wednesday. Yeah. So actually, you may be sleeping still at that point because that class is going off at 9 o'clock in the morning, East Coast. So it's 6 a.m. for you guys. So that's the Eastern Energy Expo. Come by if you want to see the new controls. We're going to have that. We have a nice hands-on display on how to work it and use that control itself. as well as other stuff at that show. So one of the other things that's going to be at this show, I've got a few of my guys that may be online tonight, I'm not sure. We're doing a boiler build on the trade show floor. All right, so how do you build a boiler room, parts, pieces wise? Now I've got a couple of contractors, a couple of my influencer friends that are out there that we've got working the show, and they're coming out. They're setting up a boiler. They're going to be talking about how to build it and why, what goes where and why. All right, and they're using best practices. All right, from what they feel out in the field is good practice. All right, so we've got a lot of trade schools coming by. We've got a lot of people coming into this. Again, this is going to be next week, Tuesday, Wednesday, in Atlantic City at the convention center.
Very good.
So, training classes, I think, they're going to be at Harrah's, if I remember correctly. So the training classes are going to be at Harrah's. All right, that's the home hotel. And if you're not sure, just look up Eastern Energy Expo online. It'll give you all the details on everything that's happening. So anyways, any questions while I've been droning on and letting people type questions in too?
A lot of stuff came in. A lot of stuff came in. Here's one. Do you guys foresee anything new coming to your zone valve line down the pipeline, like new products or versions? Not at this time. I mean, we have a pretty solid zone valve lineup. The Zone Sentry's, in our opinion, the best zone valve out there. And we have it in sweat, press, threaded,
inverted flare, geothermal, GHW, low voltage, line voltage, three-way.
Three-way. Yep. Yeah, I mean, you name it. It's a pretty robust and complete lineup.
Normally open, normally closed.
Yeah. and normally ambivalent. That's a third one. It doesn't know whether it's open or closed. It's trying to decide. The 571 zone valve still exists. We've been selling that sucker since the 50s, more in one format or another, but the concept remains very, very sound. We still sell a ton of those, not as many as we used to, because the Zone Sentry's taken so much of that market, but we have those. We did have a synchronous motor zone valve for a little while, kind of like for an El Cheapo, like a Honeywell, before that price-sensitive market. We don't really still sell that, do we?
I think we just discontinued it.
Discontinued because it just, you try and it doesn't gain any traction. Like, well, why? Why sell?
We made some improvements to it. We changed from some of the plastic gears to metal gears on the inside. Some of the main, the common failure points.
Yep.
We still didn't get much traction on it. People preferred the 570 and the Zone Sentry to that. And when they looked at the price sensitive behind it, they said, we'd rather go with what these are, even though they might be expensive. It's still a better value because it's easy to change out, and changing out a power head on its own Sentry takes about 3.5 seconds if you're slow. So it's one little tab, pull it off, and you're done. So yeah, we just continued that last year. Yep.
Okay. Another question, could you talk a little bit next week about the hydro air control for hybrid systems?
The HAFC.
Yeah, the HAFC.
Okay.
That's a pretty neat little.
Right. We didn't do any changes to that control. That's still an existing control, so we haven't changed much on it. But
not much change. It's pretty straightforward.
It's a straightforward single zone system. I mean, I'll talk about it now, even too, while you're here with me. Those of you that asked, it's a simple controller, as in you got your thermostat tying in it. But one of the things it also has tied in is you can turn on the pump, obviously, like a SR501 would. But then it also has your interface to your air handler to turn the fan on and off with a temperature sensor to make sure the water got hot before you turn the fan on.
Right.
And it does have the landing points that you can put all of your thermostat, not just the R and W on there. You're also dropping in your W and and getting out to your condenser. To the air handler itself through the HAFC, which looks like a 501 controller, just with a few more terminals on there. So that's the basics about it, but it can handle quite a few different things, a lot of different scenarios. So I'd have to pull up some wiring diagrams and look at it in some more detail. Yeah. Who was asking by chance?
That was that was Ryan. No, that was Douglas Specht.
Okay, gotcha. Yep. Because I figured it would be like somebody like Doug or Rich McGrath out there that are very familiar with the take line, because a lot of people don't even know we have it.
Yeah.
We like to make stuff and not tell anybody. It's just hard. It's
Because
just
you'll only
hard to
just
keep
go out there and
in the
buy.
front of everybody's mind on everything that we do, you know? So, because everybody does obviously ask us about pumps all day long,
Mhm.
right? We had this conversation today.
Right.
You know, the circulators is about 20% of our business,
Mhm.
you know, when it comes to take overall, not just the residential side. On the residential side, yes, it's high, but we get all the way to the commercial side of things. Now, all of a sudden, you start looking at circulators as a small part of the business. And
You get the big
it's
commercial.
hard to make sure everybody knows everything that we make. It's crazy. Yeah.
Right. And if you do look at our catalog, it's astounding how really wide and deep it is. We have, you know, I mean, nobody matches us part for part in the industry. We just cover, we have so much. There are people who might have portions of the catalog that are their specialty, that have more options than we do, but we have the full catalog. So it's if it makes sense for people, you know, that's kind of more of a wholesaler thing, you know, it's your one-stop shop. But it's just take a look at our catalog sometime, and you'd be kind of interested in all the crazy stuff we have. So.
Excellent. Any other questions coming through there as we've got rats fighting behind my head here?
Let's see. Most guys signing off. Eugene Regal says, I remember a lot that you've done over the years. I just don't want to give away my age. I'm feeling you, man. I know that story too.
Dave might be feeling it too. I think somebody has a birthday tomorrow.
Is your birthday tomorrow?
It is tomorrow.
Hey.
Yes, sir.
Might be, you know, feeling a little bit older tomorrow.
All right,
I will be, yes.
we've still
Yeah.
got a bunch of people out there. All of you guys out there, let's just all together. You out there in webinar
What's
land.
we gonna sing?
Inagata DeVita. What the hell is wrong with you? Of course you're going to sing happy birthday. Oh, Jesus.
I know. It's always fun.
Ready? Happy birthday to you. Happy birthday to you. Happy birthday, dear Davy. Happy birthday to you. And as we finish, all the rats are cheering behind you.
Yay. I apologize, everybody. You had to all listen to that just now.
There
Too,
you
at the
go.
same time.
We were we were like the Everly Brothers, you know?
Too funny. Too
There we
funny.
go.
Thanks, guys. Greatly
All right.
appreciate it.
Thank you, everybody out there. Have yourself a fantastic evening, and it was really good to spend this time with you once again. Thank you so much.
I guess I'll be seeing you all next week. I was trying to take off. Guess not.
That
See you
ain't
next
gonna
week.
happen.
I can't do it.
We
Yep.
got you next week, brother.
All right. Thanks, everybody. Enjoy. See you
So long.
soon.
So long.